Hi children, so today we are continuing electromagnetic induction. So the topic under discussion today is induced EMF in rotating coils. Induced EMF in rotating coils. So before that we will do a quick recap. So what we have studied, the change in change in flux. Yeah, change in flux will induce EMF in a coil. Okay, so if it is a closed circuit, there will be current passing through this. Okay, so E is equal to, that is induced EMF is equal to, okay, change in EMF, okay, in a time duration, or we can say that d phi by dt, and this phi is nothing but B dot A, that is BA cos theta. So theta is the angle between magnetic field vector and area vector. Theta is the angle between magnetic field vector and area vector. Okay, so this is what is Faraday's law also, and we have seen Lenz's law in order to find the direction of current. Okay, so the direction of current will be in such a way that it will be opposing the effect which is making this induced EMF or current. Okay, so with this recap we will be continuing, and hope you have revised it and came here. So sit with the pen and paper, everything. Then please don't sit generally just like watching a general video. Okay, definitely you should sit on a table, okay, with a proper posture, with a paper if you are taking notes on paper, or book if you are taking notes on a book. Then watch the video. Wherever you need to note it down, pause the video, take the notes, then continue like that. So do it in a disciplined manner, okay, then only this is going to be useful, otherwise we will forget after the lecture. Okay, right, so we will do this problem and we will proceed the session. Okay, so the problem is a circular coil is rotated in a uniform magnetic field, okay, and magnetic field B is given 4 into 10 raised to minus 2 Tesla about a diameter. Means if this is the, it is given, so if this is the axis, if this is the axis of the rotation, okay, so it is just like this is the coil, okay, and this is the axis of rotation, and magnetic field, okay, if it is kept into the plane, okay, into the plane. So suppose if we consider like this, okay, if this is how, if we keep the coil, this is the area vector, this is the magnetic field vector, definitely what will happen, flux will be what? Zero. Flux will be zero. So what we should consider is, see, this coil, okay, we will take in, if we consider like this, then the flux will be zero. Okay, suppose, so what we will do, we will keep the coil like this. So we'll keep the coil like this, then we will rotate like this. So if this is the coil, and if we consider the area vector in this direction, not this one, this one, this is also fine. So I am considering the area vector going inside, magnetic field is also going inside, then phi is equal to B dot A is not zero. Okay, so this is how the coil is. Okay, so a circular coil is rotated in a uniform magnetic field about a diameter, and area of the coil is given as 25 centimeter, and frequency is 300 RPM, rotations per minute. The resistance of the coil is given as 2 ohm. So the question is, find the induced EMF, induced current and charge. Okay, first question is in half rotation. if this is rotated half, just like this, in a half rotation, what will be the induced EMF, induced current and charge? Okay, so hope you have noted down the question. Okay, so I will write the values here, then we will do the problems. Okay, let the figure be there. Okay, fine. So the magnetic field is given as 4 into 10 raised to minus 2 Tesla. Okay, 4 into 10 raised to minus 2 Tesla. Area of the coil is 25 centimeter square, and frequency is given as 300 RPM. What else is given? Okay, right. So yeah, resistance R is equal to 2 ohm resistance is also given. So either when we take the loop, either we can keep the loop like this and we can consider the direction like this, or otherwise we can consider the direction like that also. If we consider the direction like this, magnetic field in this direction, one additional negative will come. When it turns this side again, it will change. So better take easy thing. Okay, why to go different directions? Okay, so take the things as in the way it is, it makes our work easy. So phi initial, okay, suppose if this is how it is, magnetic field is inside, area vector is also inside. If we consider, then phi is nothing but BA. Okay, then phi final is what? This is how it is. Now it is changed halfway. First what we will do, half rotation we will do, half rotation. So if it does half rotation, then what will happen? Area vector will come to this side, magnetic field will vector remains in that direction. So this is BA cos theta. Okay, so what we will be getting? BA cos 180. Okay, so what we will be getting? Minus of BA. So now what is the induced EMF? Induced EMF is delta phi by delta t. So this is the time duration. So if we take this final flux, okay, final flux minus initial flux divided by the time duration. So what is the final flux? Minus BA minus of initial flux is again BA divided by delta t. So this is going to be minus 2 BA delta t. So the time duration, it is not given in the question. Time duration is not given in the question, but frequency is given here. So frequency is actually 300 RPM, that is 300 rotations per minute. In a minute 300 rotations will be done. So what we can do, we will make it in second. So 300 rotations per minute, if we need to do per second, then we will have to divide it with 300 rotations per minute. So we will divide it with 60. So this will be cancelled off, we will be getting 5. Okay, so in a second 5 rotations will do. So what is the time period then? So time period is equal to 1 by 5. So this is time period is what? Time taken for full rotation. So this is time for full rotation. Time for full rotation. So here this delta t is for half rotation. So time for half rotation means t by 2, this is going to be 1 by 10. So when we substitute it here, what we will be getting? We will be getting EMF E is equal to minus 2BA divided by 1 by 10 means we can write this is into 10. Clear or what? Okay. So we'll substitute. Okay. So E is equal to minus 2 into 4 into 10 raised to minus 2 into 25 into 10 raised to minus 4. Okay, centimeter square. Okay, centimeter 10 raised to minus 2, centimeter square 10 raised to minus 4, and this is divided by delta t. If we put, this is going to be 1 by 10. So finally what will happen, into 10 will come, so this is 4 into 25 is 100, so 100 and 10 raised to minus 2 can be cancelled. Okay, so now this is 2 into 10 raised to minus 4, 10 also will go up, so this is going to be 2 into 10 raised to minus 3. So 2 millivolt is the induced EMF, correct or what? 2 millivolt, this is the induced EMF. Fine. Okay, 2 millivolt is the induced EMF. So what is the induced current? Induced current I is equal to E by R. So 2 into 10 raised to minus 3 divided by this resistance 2. So this is going to be 1 milliampere. Okay, so this is 2 millivolt and 1 milliampere. Okay, so this is the induced voltage and current. Now they have asked what? One more question is the charge. So what is the formula for charge? Delta phi by R. So this is the formula for charge. Suppose if they ask what is the charge, then the formula is this one. Charge is equal to delta phi by R. So this we will get through. We can derive this from the equation of current also. So the answer for charge is equal to delta phi is what? Delta phi is minus 2BA and divided by resistance is 2. So this can be cancelled off. We will be getting 4 into 10 raised to minus 2 into 25 into 10 raised to minus 4. So this is 100. This can be cancelled off. 10 raised to minus 4 is the answer. 10 raised to minus 4 is the answer. Clear? Fine. Okay. Right. So now we will do for half rotation. This is for full rotation. Now we will do it for half rotation. Right. So for full rotation, already we have done for half rotation. Now this is for full rotation. So phi initial, if it is BA, phi final, it is nothing but minus BA for half rotation. This was the coil side, then flipped, half rotation minus BA chord. But it is the same thing. If we are rotating it is full, then initial position and final position both are same. Already the coil was like that. This is rotated half. Okay, then again it is rotated full. Okay, this full rotation, just how to show this. Suppose if this was the initial position, okay, this was the half position, full position means again it will come back to the previous position. So if that is the case, then what is the change in flux? Change in flux, phi final minus phi initial is nothing but BA minus BA is equal to 0. So induced EMF also will be 0, induced current also will become 0. What? Charge also will be 0. Clear? So for a full rotation, the change in induced, the change in the flux change in the flux will be 0. Okay children, change in the flux will be 0. Is it causing confusion? Okay, because the entire concept of AC, everything is based on this rotation. So I could say that this induced EMF and induced current is actually the average value. What we are measuring is average value. Already we have seen E is equal to delta phi by delta phi by delta t. This is actually what? Average value of induced EMF. E is equal to, negative will come, but we don't mind negative much, just because the direction of current we will take from Lenz's law. So E is equal to d phi by dt. Okay, this is what is instantaneous value. Instantaneous value. So the average value we will get as 0 for full rotation. So for full rotation or for full cycle or full period, definitely we will be getting the average value as 0. Okay, instantaneous value means what is at a particular instant, what is the flux if we try to measure, or what is the EMF if we try to measure. Definitely that won't be 0. Okay, only at certain points that will be 0, but remaining all the time we will be getting some values. Okay, so we are getting 0 just because we have taken the average value. Okay, clear? Now see children, phi is equal to b dot a, or phi is equal to BA cos theta. So this theta is the angle between what? Between the area vector and magnetic field vector. So E is equal to actually what? Or I could say the magnitude of induced EMF is d by dt. So I could say that d by dt of BA cos theta. BA cos theta. So if I could change this magnetic field, then also induced EMF will come. But big magnets I have kept both sides. This is north pole, this is south pole. So in between, if I am the coil and if I am rotating like this, clear? So moving this big magnets, changing this big magnets, can we do this? Big magnets, every second changing the big magnets, who can do that? Your heroes, no? Just Avengers, only those people can do that. Okay, they are not there in the real world. So that is not possible. So always what will happen, for problem sake, for doing problems, for scoring marks, we have done problems where this magnetic field is changed. But practically, magnetic field cannot be changed easily. So this B will be what? Practically what? Constant. Practically this is going to be constant. Okay, area, if I am the coil, then increasing the area, decreasing the area, increasing the area, decreasing the area, is it possible? Generally, when we take any coil, decreasing, increasing the area, it is not possible. It would have been possible, increasing, decreasing the area through this artificial intelligence or through robotics. We could have increased and but that also required current, right? Okay, this mechanism is actually for making current. Alternating current is done by using this method. So that requires current. So practically speaking, this is also what? Constant. Okay, practically speaking, this is also constant. But d by dt of cos theta. What is cos theta? If magnetic field is in this direction, area vector is also this direction. If a coil changes, this is magnetic field, this is area vector. Angle between them. Again changing, this is magnetic field, this is area vector. So 90 degree. Again changing. So if I rotate like this, that is if I am the coil, if I rotate like this, the angle between this one, area vector, and magnetic field vector can be changed. So if we could rotate the coil, then that is the most feasible method for getting induced EMF. So this can be what? This theta can be changed just by rotating. Clear? And you know, omega is equal to theta by t. I could write like a theta is equal to omega t also. So theta is equal to omega t. If I substitute, the magnitude of induced EMF can be written like d by dt of cos omega t. Cos omega t. So if we remove this mod, one negative can be put here. One negative can be put here. If you differentiate this one, what answer will be getting? So E will be equal to, this negative is there, BA cos omega t is what? This will become sin omega t. One negative also will come. This will become positive. Along with that, one omega also will come out. Okay, cos omega t, if we differentiate, this omega will come out. Again, cos omega t will become minus sin omega t. So the induced EMF is what? BA omega sin omega t. Clear or what? Okay, so this is what is the induced EMF if we keep on rotating the coil. That is the formula for induced EMF if we keep on rotating the coil. Okay, copied, done, copied. Okay, right. Okay, so the induced EMF E is equal to what? BA omega sin omega t. If there are some n number of turns, definitely that will increase the induced EMF. So definitely we will go for what? N turns. Okay, we will go for n turns. So if we get n turns, then E is going to be NBA omega sin omega t. Okay, so this is the formula for induced EMF. And the maximum value of induced EMF, when we will be getting the maximum value of induced EMF, when we will be getting when sin omega t is equal to 1, that is omega t is equal to, or theta is equal to 90 degree. So that time whatever we are getting is the maximum induced EMF. So E max is equal to NBA omega. Conventionally this is denoted as E naught or EM. Okay, so putting that NBA omega is nothing but E naught, I could say that E is equal to E naught sin omega t. Okay, E is equal to E naught sin omega t. Clear? Suppose if we try to measure the current, then this is nothing but E naught by R sin omega t. Both are correct. E is equal to E naught sin theta, I is equal to E naught by R sin theta. Clear? So this is the formula of AC signal that we will discuss in the next chapter. But when a coil rotates, keeps on rotating, then the induced EMF, if we need to find the instantaneous value of induced EMF, this one. If we need to find the instantaneous value of current, this one. Someone is asking what is the EMF at a time t is equal to 1 second. Put time here. T is equal to 1. What is the induced EMF when the time is equal to 0? Put 0 here. We'll get the answer. What is the induced EMF if the angle between magnetic field and area vector is 30 degree? Put 30 degree here. So situation at a particular instant of time, at some angle, at some time, what is the value of induced EMF, current, everything. Instantaneous value. Oru nodi. Okay, instantaneous value. These are the formula. Dear children, okay, hope you understood. Okay, clear? So this is what? Induced EMF, instantaneous value. Instantaneous value of EMF and current. Clear? Okay, so I will summarize. Okay, so average value okay, EMF current, this is actually delta phi by delta t. Okay, delta phi by delta t, and this one delta phi by delta t divided by what? R, or simply we can say this is nothing but E by R, average value. Full cycle, half cycle, we will get a value. Full cycle or full time period, definitely we are going to get 0. And instantaneous value, the general formula is d phi by dt. So here what we do actually, BA minus BA, okay, BA minus of minus BA, likewise d phi by dt. So its value is going to be E naught sine omega t, or E naught sine theta. What about this current? I is equal to E naught by R sine omega t, or E naught by R sine theta. So this is the instantaneous value and this is the average value. Clear? Okay, so we will do a problem on this. Okay, so one thing which we need to understand here is, what kind of signal is this? Sinusoidal signal. And this maximum value of E naught, what is that? NBA omega, NBA omega. So here we can write one more thing. This E naught by R can be written like I naught, which is nothing but the maximum value of current. I naught sine omega t. So this is maximum value of EMF, and this is maximum value of current, right? Clear? Okay, note it down, right? Suppose if we need to draw this signal, then sinusoidal signal means this is how it is going to be. Okay, and this maximum value is E naught. Okay, so this signal is nothing but E naught sine omega t. So this is the value of EMF. This can be time or angle. Okay, theta is also fine. Same way for I naught sine omega t, this one. This will be I naught, and this is nothing but I naught sine omega t. This value is the value of current, and this is going to be time or theta. Both are fine, theta or time, omega t or time. Clear? Okay, students, take this question. A circular coil of area 300 centimeter square. Okay, area 300 centimeter square and 25 turns, rotates about its vertical diameter. Okay, so suppose if the coil is like this, okay, this is vertical diameter, so this will be rotating like this at an angular speed of 40 radians per second. So omega is 40 radians per second in a uniform magnetic field of magnitude 0.05 Tesla. Okay, so magnetic field is given as 0.05 Tesla. Okay, so suppose if the magnetic field is moving like this, then if the coil is like this, if it is rotating like this. Okay, so what is the question is like what is Emax, maximum EMF? So Emax is nothing but what? NBA omega, NBA omega. So N is 25, magnetic field is 0.05, area 300 centimeter square. Okay, and omega is given as 40. Omega is given as 40, right? So 25 into 40 is 1000, 10 raised to 3. So if we cancel with this, this will become 10 raised to minus 1. So this 10 raised to minus 1 and this 0 can be cancelled. 5 into 3 is 15. Okay, 0 is here, 0.05, so we'll put that. Answer is C. Clear or what? Fine. NBA omega. Clear? Shall we do the next problem? Okay, read this question, children. A rectangular coil of dimension 0.2 meter into 0.1 meter length and breadth with 2000 turns is rotated in a magnetic field about an axis parallel to its length. That is, parallel to its length means, suppose if the coil is like this, okay, so it is rotating like this. This is what is length, this is what is breadth. So rotate, and this is perpendicular to the magnetic field. So magnetic field direction will be like this. Okay, speed of the rotation is 4200 rpm. Okay, so calculate Emax. So what is Emax? Emax is going to be NBA W. So what is the number of turns? Yes, 2000 given into what is the magnetic field? 0.02 Tesla or Weber per meter square, both are its SI units. Then area is 0.2 into 0.1. Then what? Omega. So 4200 rpm. So actually then if we take its omega value, this is nothing but 2 pi f, right? So 2 into pi into f is what? 4200 divided by 60, correct? So if we substitute that, we will be getting the right answer. So this into 2 into 22 by 7 into 4200 divided by 60, correct or what? So I'll write it clearly. Hope you have noted the question. Clear? So I'll write here. So this is going to be NBA omega 2000 into 0.02 into 0.2 into 0.1 into 2 into 22 by 7 into 4200 divided by 60, right? So simplify this. Okay, simplify this. What we will be getting? Somewhere around 352 volt we will be getting. So this is the Emax. This is what is Emax. Clear? Now what they are asking, another question is, when the coil is rotated through an angle of 30 degree from initial position, what is E? So E at when the coil is rotated through an angle from 30 degree. So what is E? Emax sine theta. So 352 into sine 30. Sine 30 is 1 by 2. So half of this, 352 divided by 2. So this is going to be 171 volt. So this is the instantaneous value of EMF. EMF when the coil is at a 30 degree angle. So maximum EMF is 352 when it is turned 30 degree. That is instantaneous value. The EMF at instant 30 degree. 171 volt. Clear? Hope you understood. Clear? Suppose if I get a question like this, this is the magnetic field. This is the magnetic field and the coil is like this, and this coil is rotating like this. Coil is rotating like this. If it has n turns, area is A, okay, and this magnetic field value is this, then what is the maximum EMF? Can we write NBA omega? Is it correct or is it something else? What is the answer? What is your answer? Okay. If you are saying NBA omega, this is wrong. Thing is like here, this is simply rotating. Magnetic field is constant. Area is constant. N is also constant. At least the angle should change. So if this is the coil, this is the direction of magnetic field. If this is the coil, this is the direction of magnetic field, and this red color, if this is the green color, this is the direction of area. If this is area, this is magnetic field. Okay, if this is my palm is coil, this is area vector and this is magnetic field vector, both are parallel. So even if I rotate this coil also, the angle is also not changing. Angle is always, this angle is what? Theta is either 0 degree. If we take the area vector also inside, 0 degree, or otherwise theta is equal to 180 degree if we consider the area vector out of the board. This is not changing. So nothing is changing in this flux. So EMF will not be induced. So the answer is going to be 0. Clear? Okay. So here children, see, this is another expression for induced EMF or induced current. Suppose a coil, okay, with a shape like this, okay. Suppose if it is rotated, okay, it is rotated in the magnetic field. Okay, you see this figure. So this is a coil, a semicircular coil, and it is rotating inside, then it will come out, going inside, coming out. So for the coil, when it is going inside, cross magnetic field is increasing. Okay, then cross magnetic field will become full when it come like this. When it reaches this position, cross magnetic field will be full. Then it will be coming out. When it comes out, the cross magnetic field will be decreasing. Okay, so likewise. So what will be the induced EMF and current? So suppose, so this is figure 1. Okay, now let us consider, okay, this is figure 2. Let us consider this is in this position, that is it has gone a little inside, okay, at an angle theta. So we can write like E is equal to what? D phi divided by dt, and phi is what? Phi is BA cos theta. Okay, so instantaneous, if we try to find the instantaneous value of EMF, then we can write like a E is equal to d phi by dt, and phi is equal to BA cos theta. Okay, so BA, when I say BA cos theta, what is theta? Theta is actually 90 degree, not this theta. Okay, if this is the area and inside area vector is going, magnetic field vector is going, so this theta is not changing, not 90 degrees, sorry, 0. So magnetic field is also going inside. The area vector of this loop, and magnetic field vector, both are what? Going inside. So theta is equal to 0 and phi is nothing but BA. So what is changing here? Area is changing here. Okay, so what is the area of this part? suppose, okay, so if we have noted down this, shall I erase this? Okay, so then effective resistance of the loop is also given R. Effective resistance is also given as R. So suppose if there is a rotation of 2 pi radians, then what is the area of that complete circle? If there is a rotation of 2 pi, that is, if we are sweeping like this, then that full area is what? Area is equal to pi r square. So I could write like a 2 pi radian sweep, I will be getting pi r square. So 1 radian sweep, I will be getting pi r square divided by 2 pi. Do you agree with me? For 2 pi sweep, pi r square area will be covered. Okay, so 2 pi radian sweep, pi r square means 1 radian sweep, pi r square by 2 pi. So in this case, this is theta sweep, we can say this much area we can consider. So for theta radian, I could say that this pi will be cancelled off. I could say r square by 2, r square theta by 2. Okay, so this is the area what we have now. Okay, half r square theta I can say. So I could write, okay, I could write phi is equal to b into r square theta divided by 2. So if I theta, for theta, if I write omega t, then I could say that phi is equal to br square omega t divided by 2. Clear? Now if we put this, E is equal to d phi by dt, E is equal to d phi by dt, d by dt of this one, br square omega t by 2, I could say that 1 by 2 b, r square is nothing but the radius. Okay, this radius is what is r, that is also constant, and this omega with an angular velocity is rotating, that is also constant. Then we can say that d by dt of t is equal to 1. d by dt of t is equal to 1. Clear? So induced EMF, how much I get? Half br square omega I will be getting. Induced EMF is equal to, can I erase this? Okay, so induced EMF is going to be half br square omega, where r is equal to radius, and induced current is equal to half br square omega divided by r. So this capital R is nothing but resistance. Okay, so this is the formula for a rotating loop inside, okay, the magnetic field. Suppose, okay, if it is rotating like this, this is what we will be getting. So this does not depend on time also. Okay, it depends on magnetic field, radius, omega, and resistance. Clear or what? Fine. So this is the magnitude of induced EMF and current. Now suppose if you need to find the direction of current, you can use Lenz's law. If it is increasing, if it is going inside, then cross magnetic field will be increasing. So this will induced EMF will be trying to decrease the cross magnetic field. So dot magnetic field will be increasing. So dot magnetic field means coming out. So current direction will be anti-clockwise or otherwise clockwise law. So likewise, we have done enough practice on Lenz's law, how to apply. Same thing we can apply here. If you have watched that full lecture and if you have understood it and if you are revising it properly, this is nothing for you. Okay, finding the direction of current. If you are still have confusion in finding the direction of this current, you should watch that second video of this lesson. Okay, just previous session you should watch again, and please give proper concentration and see that we have discussed a lot of questions, almost all the cases we have discussed there. Okay, so just finding the magnitude of EMF and induced current will be done using this, and the direction of current can be found using the Lenz's law. Okay children, so this is not that motional EMF. Suppose a conductor is moving like this, or a conductor is moving like this, that is motional EMF, that is different. This is the loop itself is moving inside. Okay, so we have understood like what is the instantaneous value of induced EMF and current. Then if a coil like this, if it is moving inside coming out, then what is the induced EMF and current, all these things. Okay children, please keep focusing on the subject, study well, practice more number of questions. Goodbye, good luck.